once you get an equation for one of these problems, all you do is you take the derivative, set equal to 0, and then you're back on home turf at that point, aren't you? Okay. But the catch on these problems, on these application problems, is how do you get the equation? That's the tricky part on these. So let's take a look at number 5. Chelsea said she was having a good time with that. It says Greasy Oil Incorporated sells 1 million barrels of oil a day at a price of $51 a barrel. Surveys indicate that for each 30-cent increase in price per barrel, 5,000 less barrels are sold. What selling price will optimize the daily profit? How many barrels will be sold? And what's the revenue? Okay. So, Sophia, we're working on this sheet, number 5. Do you have a copy of it? Great. All right. So, to get things started here, let's see here. The current price, there we go. The current price is $51 a barrel. Okay. And let's see, for each 30-cent increase, it results in a decrease of 5,000 barrels. Okay. What we want to do is we want to optimize the revenue. Now, by optimize, does that mean to maximize it or minimize it? What do you want to do with revenue? Maximize it. So we want to maximize the revenue. And is there a formula for revenue? Kind of a general template? Price times quantity. Yeah. So I'm going to jot that down. It's whatever the price is times the quantity. Or in some cases, people know this as the number sold. Okay? Either's fine. So there we go. So our maximizing revenue is the objective. What are we trying to figure out here? What's the number that's going to drive everything on this? What decides how many barrels are sold? Maybe something like price? Okay, yeah. Tesla just announced, I don't know if you heard this or not, they rolled out yesterday a new electric pickup truck. How many of you are going to go out and buy one? Nick's shaking. He said, why not? They're expensive. Price controls a lot of things, don't they? Why don't your mom and dads all live in Indian Hill? It's a nice place. Yeah, right. Dream on. Okay? Same thing. Price controls a lot of things in life. Okay, so what we need to do are two things. We need to determine a price. We need to determine a number that are going to be sold. Okay. The main thing here is to figure out a price. I'm going to call X is going to be the price per barrel. What units will X be in? Dollars? Sounds like it, because the price now is $51 a barrel. Oh, wait a minute. They gave us a price, didn't they? Huh. So it's right now 51. And what can we do with the price? We can raise it and lower it, can't we? And the information that we have is in raising it and lowering it how much? 30 cents. Okay, so maybe is X going to be the final price, or is X going to be how many times we raise or lower? Yeah, what we're really after here is the change in price per barrel. Does that make sense? Oftentimes people will grab a problem like this and right away they'll say X is going to be the price. Does it make sense sense why it's not the price? Because we already have the price, don't we? And the question isn't what's the price, but what we're really after here is how much do we change the price? So X is going to be the change in price. Another way to put this would also be the number of $0.30 changes. So if X winds up being 2, what's that say we're going to do with the price? We're going to add on 2 jumps of 30 cents, aren't we? So we're going to add on 60 cents a barrel. If X winds up being a -3, if X is a -3, what's that going to do to the price? Drop it 90 cents a barrel. Does that make sense? So X is going to tell us how far we're shifting things. It was kind of cool. Daniel had a hockey game last night in Oxford. You know how much gas is selling for in Oxford right now? $2.18 a gallon. Everywhere in town. So if you got a really big tank and you need to go north, there's the place to fill up. It's not worth going up there for 4 gallons though, is it? Okay. So what we're going to wind up doing is not treating X as the price per barrel, but X is going to look at how far from $51 are we going to move. Okay. So what's going to wind up happening here is our actual price, looking at this revenue function, the way that we're going to describe price here is it's going to be 51, the current price, plus, now I'm going to intentionally mess something else up here, just like I messed up the label on X, right, to draw your attention to the fact that X is not the price, it's the number of times we're going to take a jump of 30 cents. It's going to be 30X, where X is the number of times we're going to change the price by 30 cents. What's wrong with that equation? That's right. It would be 0.3 because, remember, the 30 is not in terms of dollars, is it? The 30 is in terms of cents. Something that will often trip people up is they'll mix units. Part of the equation will be in dollars, part of it will be in cents, and it makes a big mess. So what we really need here is 0.3. Now I could put another 0 there, but it's 0.3x. And remember, x is the number of steps we're going to take in price change. Does that make sense? Okay, so that's got that. What are we going to do next? Well, we have the price taken care of, don't we? That's right there. What's left in our revenue equation? The quantity. So what we need to do is we need to figure out what the quantity is. At $51 a barrel, how much are they selling a day? 1 million. And if we raise the price, is the number of barrels sold going to increase or decrease? It's going to decrease, isn't it? So what's going to happen is, if we leave the price alone, we're going to sell 1 million barrels. Okay. Every time we increase the price 30 cents, how many barrels don't get sold? 5,000. Okay. So what's going to happen here is we're going to subtract 5,000 for each increase of 30 cents. Now, something to notice as well is if x equals a -2, that means you're going to do what to the price? Going to decrease the price. happens in the quantity equation if x is negative? If x is negative, what happens to the quantity sold? Well, that would be something like putting in a -2 there, wouldn't it? And a -5,000 times a -2 is going to give you a positive or negative number? Positive, isn't it? Would it make sense that as the price drops, more is sold? Yeah. So that's fine to have this working in both directions. Okay, so we've got our price written as an equation, our quantity, number sold, written as an equation. So what's going to happen next is we can write down our revenue equation is going to be this 51 plus 0.3x times 1,000,000 minus 5,000x. Does that make sense? Everybody's good there? Okay. Just checking, reading over. Yeah, it's $51 a barrel. Where do we go from here? Any suggestions? Well, let's see here. The objective was to maximize the revenue. Do we now have a revenue equation? Yeah. We have a revenue equation. And what we want to do is we want to optimize that revenue equation. We want to maximize it in this case. Does this sound like we're back home? To maximize or optimize something, you take the derivative, set it equal to 0, all that good stuff. However, before I go taking the derivative, what might be a good idea to do with this revenue equation? You want to take the derivative of that as it sits there? Looks like a product rule, doesn't it? That's going to get kind of messy. Instead of using a product rule, we can either pay the price later by having a messy derivative and solving a messy derivative equal to 0, or we can pay the price now by FOILing things out. Okay? You're going to pay the price either way. So we'll do the first times the first, which will give us 51 million. Minus the outer two. Well, we know it's going to have 3 zeros. And it's going to be a 5, from where it multiplies by the 1, and then a 25. X. So that's got that term. Then we do the inside 2, which is going to give us plus. Let's see, that's going to be 300,000 X. And then we do the last two. This is going to be a minus. We're going to have an x squared. Now, if we take 0.3 times 5,000, that's the same thing as taking 3 times 500. Does that make sense to everybody? Okay, which will give us 1,500. Okay, the revenue function in terms of x is going to be this negative 1,500 x squared. That has that taken care of. We have 300,000 minus 255,000, which is going to give us plus 45,000 x plus 51 million. Everybody good so far? I haven't messed up any of the numbers? They're kind of big. Okay, so now we have a revenue equation. Yahoo! We're ready to start the problem. Well, the first step in maximizing or optimizing is to compute the derivative. Oh, wait a minute. Before I even start that, take a look at this revenue equation. It's a quadratic, isn't it? knowing it's a quadratic, you can look at it and decide, does the thing open up or does it open down? Opens down, doesn't it? Do you see it, the negative 1500 on the x squared term? That means it's opening down. If it's opening down, is this function going to have a max or a min point? It's going to have a max point, isn't it? Well, that's good news because we're looking for a max. What if it would have been a min point? What if it would have been opening up? Well, my thought would have been, uh-oh, messed up something somewhere. I'm going to go back and recheck things. Probably the mistake would have been up there where we were foiling stuff out. But everything looks to be okay so far. So I'm going to compute the derivative, which is going to be a minus 3,000 x plus 45,000. And when I take this derivative, I'm going to set it equal to 0. Setting it equal to 0 is going to give us 45,000 equals 3,000 x. Each side has 3 zeros, doesn't it? We could divide both sides by 1,000. Okay. And if we divide by 1,000, that'll give us 45 equals 3x. And that'll give us x equals what? 15. Holy mackerel. Is that good news or not good news? For you and me, when we pull up to the gas station, is this good news? What does x equals 15 mean? 15 increases of 30 cents. What this is suggesting is they should do what with the price of the crude oil? Raise it. Well, if they raise the price of crude oil, what happens to the price of gasoline? Goes up. Okay, so x equals 15. All right, with x equals 15, what are some questions that your boss is going to be asking you? Well, what's the new price per gallon? How many barrels are going to be sold? And what's the new revenue? Not price per gallon, price per barrel. First thing we can do is we can compute the selling price. So the price per barrel is going to be this $51 plus 0.3 times 15. It's going to be $51 plus 4.5, which is going to give us a new per barrel price of $55.50. Anybody ever heard of OPEC? What is it? What's OPEC? Okay, in the Middle East, the oil-producing countries there have, as much as they fight amongst themselves, gotten together as far as economics and said, okay, if we all team up and we set a common price for oil per barrel, we have some control over what the price is going to be. Okay? And for a long time, they pretty much set the price of oil. Now, in the last few years, last 3 in particular, there's been a new player on the scene. Anybody know who the new oil producer is on the scene? The U.S. Who has the largest oil reserves in the world? Russia? Saudi Arabia? The U.S. does. The U.S. has more oil than the Middle East. And when they started pumping the oil, suddenly there was a new kid on the block pumping lots of oil. And what did that force OPEC to do to their prices? Because there was now competition from the U.S. brought more oil in than we sold. Now we're a net exporter. In other words, the U.S. produces more oil than we can actually use, and we sell the rest. So we sell a chunk of it here in the U.S., you're in my car, and then sell the rest to Europe or whoever. Okay. All right. Price per barrel, $55.50. Number of barrels sold. Oh yeah, that's kind of important. Is it going to be more or less than we were doing before? It's going to be less. Well, the number of barrels sold, we can go up here. Here we go. It's the quantity. It's going to be this million minus 5,000x. Now remember, x has what value? 15. Does that look familiar to folks? So this is going to work out to be 1,000,000 barrels minus, well, it's going to have 3 zeros. And what's 5 times 15? 75. Okay, so we're going to sell 75,000 less barrels a day. So this is going to give us 925,000 barrels of oil per day being sold. Well, wait a minute. What this is saying is we're selling less oil but making more money? That's what this is saying, isn't it? Well, let's check this and see what's going on. The revenue, okay, so we got three things: price per barrel, number of barrels sold. The revenue is going to be the price per barrel, $55.50, times 925,000. It's going to work out to be a fair chunk of money. And this is per day. Go out and buy that Tesla pickup truck. Okay, so let's see here. 55.5 times 925,000 equals. So we're going to wind up with a 5133750. What is this number? What are the units on this number? Dollars. So this company, if they raise the price by $4.50, is going to generate $51 million a day. Now, is that the profit? No, they still got to pay everybody who works, pay for all the equipment, pay for a zillion things. Okay. How does this compare to the revenue without the price change? Before the price increase, what was the revenue? Yeah. You were selling 1,000,000 barrels a day at $51 a barrel. So let's put this as the original revenue. So originally the revenue was $51 million a day. And you may look at that and say, yeah, but it's only an extra $337,000 a day. But the other thing to keep in mind is not only is it an extra $300,000 a day, but it's also selling 75,000 barrels less. So you're selling less of your resource and picking up another $300,000 a day. Does that make sense on how to work that? They don't really do this stuff, do they? Yeah, they do. This is part of how they go about this deciding or setting the price on things. That's a fun one to work on. Thank you, Chelsea. Does this one make sense? It's kind of nice because this was one I wanted to take a look at some point here because we haven't done anything like this, have we? The question is, how do you set the price on a product? Now, I know in this case, it's oil. But does McDonald's do that on their hamburgers? Yep. Does Kroger's do this on their milk? Yep. Well, not so much on their milk. Why would Kroger's and places want milk to be fairly low price? To get people in the store. And where do they put the milk? Is the milk right up front where you can get to it? It's all the way in the back in a corner. Is it by accident that it's all the way in the back in a corner? Okay. Now, if you think about it, the way the stores are laid out, here's the doors you come in. Okay. Somewhere back in here, or depends on the Kroger's, back over in here is the milk. And as you come in, you usually kind of shoot like this or shoot like that. And you just kind of zip down one of those center aisles. What are those center aisles? Candy. Holiday decorations. Right now, Thanksgiving stuff, more Christmas stuff. So I guess it's just by accident that the milk's way in the back, isn't it? No. Every time some mom or dad drags their kid in to get a gallon of milk, they got to drag them down the candy aisle. Huh. Now, when our kids were little, being the mean dad that I am, we would come in, and over here is shampoo, and I would take them down the shampoo aisle. Because they weren't, no, Dad, I need more shampoo. Wait, Dad. Of course, then now that Lauren's 18, I keep her out of the shampoo aisle. Now she runs around on her own a good chunk. They do this game, this price setting, and looking at the revenue, looking at the profit. They do this game with every single product. Some products they use as bait to get you in and to get you to walk past other products. Does that make sense? Okay. Now you just learned a trick of the trade, huh? Or when you got some little kid in tow, whether it's yours or the neighbor's or whoever's, you always can find a way back to milk without going down the candy or the cereal aisle. Okay. Are you good on this? Everybody okay? I guess so. Okay. The answers to the test 2, all the corrections are finally in and done and all that craziness, which is why I hadn't posted them earlier, because there are other sections of the Applied Calc that I teach, and I didn't want to go giving away answers that are similar to what they might have and make theirs a lot easier than what yours was on corrections. They should post today around 1 o'clock. So there will be a blank copy as well as the answers all written out copy posting around 1 today. Hey, what do you need to be doing to get ready for the final? Yeah, I know I've never mentioned this. Working on copies of Test 1 and Test 2. It's supposed to be cold and rainy and snowy and all kinds of stuff over the weekend, so I doubt that most of you will be chomping at the bit to get outside. Okay. Print off a copy of each of the tests and start working on them. Okay. Objective, get them all right and get them done fast. Okay. And with the answers there, hopefully that'll help you. As you're reworking them, if you run into problems and you're thinking, I don't understand that. Oh, remember the one with the max and the mins, the global max and the relative max and the relative mins and the global mins? On that problem, one of the values for a max min point is out of the interval. X equals -1 was not an option because you were given something like X x equals 1 to 4 or something like that. And there were a number of people who chose x equals -1. Even though it is the lowest point or the highest point, it's not an option because it's negative. Oh, rats. Yeah. We'll figure that out later. What's going to wind up happening, here, let me see if I can pull this up quick like. What's going to wind up happening is I teach 5 classes this semester. Okay? And I'm going to allow you to come into an earlier time frame. So if your test is on Friday, I'll be also giving tests on Monday and Wednesday. And if you want to sign up to come in at an earlier time, you can. I'm trying to give you some flexibility so that you don't wind up with 3 tests on one day or something like that. That happened to me with something, I think it was organic chemistry, physics, and anatomy and physiology. That was a fun day. Okay? Obviously, I still remember it. Okay? When you're checking for the schedule, if you go to uc.edu/registrar, and registration information, look at there, academic calendars. If you check down through here and you drop down to academic calendars, okay, we can check and see where they have the, here, the current calendars, 2019-2020. Okay, so there's fall semester, 2019, spring semester. Okay, you're going to make a liar out of me. They have the exam schedule, or they did yesterday, or Wednesday when I showed another class. Right, but then they also tell you the specific day and time for the individual finals. Okay. Let's try this a different route. There we go. Aha! Exam schedules. Whew. Okay. So what's going to wind up happening is I teach a class at 8. I don't know if this will let me write on. Nope. I teach a class at 8, 9, 10, 12:20, and 1:25. So if you ever come to my office and I'm not there and you're thinking, well, what's the deal with Chuck? He's teaching somewhere. Okay? Your exam time is Friday, December 13th at 10 a.m., 8 to 10, 8 to 10. Perfect time to take a calculus final on Friday the 13th. Okay? If you're looking at that and thinking, I'd really like to be done earlier, that is fine. Okay? Because I will also be giving a test with the 9 o'clock class. Well, that's Monday at 8 o'clock. I'll be giving a test with the 10 o'clock class. That's Wednesday at 8 o'clock. I'll be giving a test with the 12:20 time. That's Monday at 1:30. And I'll be giving a test at 1:25, which is Wednesday at 1:30. Now, the deal is you can always take the test at an earlier time. You just can't take it at a later time. So on the last day of class, Friday, December 6th, I believe it is, and that is the last day to do any homework. I've got it set up that it won't let you do any homework after December 6th, that Friday, in the My Math Lab. So make sure that you get it all done by then. Okay? On that Friday, I'm going to pass around a paper and ask you to sign which time and which day do you want to take the test. And the only reason I'm asking you to sign it is so I've got something I can count up. Oh, I need so many calculus tests. I need so many algebra tests. So that when you show up, I've got a test for you. Does that make sense? Okay, so there's kind of a long answer to when your final is. And be careful because depending on the day and the time you choose, it'll 3 will be after Thanksgiving. Yeah, we will have a test 3. Yes, indeed. And right now, guess what we will have?